Hey guys, it's Cameron here from Bridge the Gap. Today we're actually here with Dean Hartley from Orthotics. Welcome, Dean. How are you?
Good. Yeah, going well. Thanks for coming.
Excellent. So, guys, we've had a few questions and we've seen a few things on the page surrounding 3D printing orthotics, the future of orthotics. Obviously, it's a huge part of our business. So I wanted to sit down with Dean, he's one of the men behind one of the biggest orthotics labs in Australia and moving worldwide as well. And, what better brain to pick than his about 3D printing devices, where orthotics are going and the like. So, Dean, how did orthotics come about? I guess that's my first question, and the one that some people have asked. How did it come about? Where did it come from? Is it just another orthotic lab? What's the go?
Well, I guess it is just another orthotic lab. Initially, that's how it started. So orthotics was, I guess, born off the back of just some podiatric clinics me and my sort of original business partner, Glenn Evangelista, had. We set up orthotics probably about 8 or 9 years ago. Yep. And it was really just we wanted to start doing in-house orthotic manufacturing, just because the technology, like CAD technology, had developed a lot, and a lot of, I guess, bigger clinics had started to then look to do it in-house, just because the technology was available, and that's really how it started. So we were just manufacturing for our clinics internally, and then it sort of naturally grew from that, through friends and networks that we had that started to use our services, and then probably about 2 or 3 years ago, where it sort of become its own sort of business, where it still supplied custom orthotics to the clinics that we had, but then also to other clinics just around Australia, and a bit more overseas than that now as well.
Fantastic. And did that start? So it started more as EVA or 3D printed, or has that tech sort of come along since then?
No, it was EVA. Yeah, our clinics were predominantly prescribing EVA orthotics, and that's what we were manufacturing in-house initially. Yep. It was a bit easier to manufacture EVA. We started doing things like used like the Amphit systems, and we had an Orthema system initially as well to do our EVA orthotics, and then we used other external labs to do the polys, the plastics and that. So EVA was the first one. It was easier to sort of manufacture. Then we started to machine or subtractively manufacture, the plastic poly devices. Mm-hmm. And then it was probably about 5 years ago. I don't actually know how it come about. I think I went to a conference overseas, and there was some 3D printed orthotics there. They were getting bashed around a bit in terms of people was thinking it was, it was too immature. It wasn't going to work. The quality wasn't there. Yep. It was sort of just pushed to the side, and I don't know. Just something in my brain was thinking, no, there's got to be something in this. Like, there's surely got to be something here, because we were machining the plastics a lot like the polypropylene, and it still wasn't easy to do. Like, it was quite difficult. It took us a long time to figure it out, and wasn't super happy with the products either. Like, just hard to get a good finish on it. Yep. And the other big thing was waste. So when we did start making them a lot, the stat that we use is we would throw out about 2 kilograms of waste per pair of orthotics that were made. So it's plastic. I have an example here, but like when you machine it, because you've got a block of plastic that's about 30 or 40 mil thick that's cut out of, so you're only making a device that's, say, 3 mil. So the rest of that tends to go to waste, and majority of the time it's not recycled. So I just thought we'd start to R&D it and just see if we can actually find a 3D printed substitute. That was the motivation, was actually a waste one.
Yep. Yeah, absolutely. And I guess following on from that, how do the 3D ones compare to the old poly? Like, is there much difference between them? Originally, and obviously now it's moved forward a lot, but how was that transition?
So it's been a long journey for us. There's a lot of R&D done at the start, because there's so many different types of printers out there, like actually hardware, different types of materials. We started with the little desktop versions where you want to print something like almost like a hobbyist printer. Yep. Print it out of like Lego, like the ABS type plastic, and see if that would work. And no, that was too brittle, and the PLA was too brittle. And then we landed on printing a lot of nylons, which is what like the sort of the newer materials for orthotics are made out of. Okay. And but it was a lot of R&D that we did, but also the materials was one side of it, was actually a software issue. Yep. Because all the main pieces of software to make orthotics in the market weren't made to 3D print.
Of course, yeah.
So we had to build our own sort of applications internally over some of the software pieces we had, just so we could actually 3D print. So that was, people just think it's material and it's the hardware, but it was actually the software components that was the most trickiest part for us.
Oh, okay. Yeah. So it started to just open that whole can of worms.
It did. We sort of ended up down this rabbit hole, and we're pretty far down it before we realised, wow, what have we got ourselves into? Right. It was a fun journey though.
It's paid off now. Okay, and So talk me through some of that R&D. I know that we've had a chat previously about sort of how you've gone about testing these materials and sort of processes you're going through, but talk me through some of the R&D that has gone into these devices, and I guess is continuing to go into these if you can.
Yeah, well, I guess the biggest part from us is we need to validate what we were doing. Like, I'm a podiatrist, you're a podiatrist. There's nothing worse than prescribing a device that it fails or it breaks or something after 3 months, 6 months, 12 months. Because we're used to using these plastic devices in the industry that just last forever. You can run over them with a car. A lot of times they've got lifetime guarantees on them. So the big thing was around material properties and strength, and so it wasn't just good enough for us to go, oh yeah, it's strong enough, see how it works, and that we needed to validate it. So what we did is we engaged with UQ, University of Queensland, really early on, and so not from a podiatry point or anything, it was actually from a materials, and we partnered with their engineering department, and we had a few sort of small government grants that we could sort of help to facilitate the costing the costs that we had to incur. But we started to print a lot of samples for them, and they would then test the material property strength, so just using standard industrial mechanical testing. So looking at how much tensile strength it takes to sort of get a sample piece and pull it apart and break it, compressive load, and look at things like fatigue testing as well. So these are just industry standard testing. So we have the same done for like poly, which is pretty readily available anyway, so polypropylene. But then we were benchmarking it against our printed materials. I say our, but the materials that we're using to print with. And some were just not stacking up. And then we landed on ones more around those nylons that were starting to really show, hang on, we can actually print this at the same tensile strength as what the polys are. But yes, it's 3D printed, obviously. So then we started down that path. Once we landed on the mechanical properties were starting to work, then that's sort of where we focused our attention.
And so I guess going back to what you mentioned before, what's the waste like with these 3D printed ones compared to the old poly ones? Similar strength.
So I said it's about 2 kilos a pair with the traditional way, like subtractively making them. And then with printed, you end up, it's probably about 30 to 40 grams per pair you have. So you can't use every bit of powder. There's recyclability issues in terms of powder quality and that. But the thing is, we still haven't actually thrown out any powder that we've done. Well, within maybe some that was failed for whatever reason, was overcooked in that. But as a whole, pretty much. As a whole, all the powder we've had we've maintained, and we actually can reuse it. Once we've bought some new equipment and we need to use some recycled powder, we can use it. So we actually still have it sitting there in our office. So we pretty much have had no waste from these ones, which is pretty neat. So we're pretty happy with that.
Yeah, mate, absolutely. I mean, from uni, we all know how much, even just learning how to make those poly ones, how much we waste, and imagine that on scale. I mean, I guess it's something that most of us don't think about, but you send away to your lab and get back whatever you get back. But with the environmental impact, it can be pretty big. So that's fantastic to not really have to waste anything.